So the OpenAI Developer Conference happened not too long ago, and the recordings that were available to the people who attended are now beginning to roll out to the rest of us. And some of them are pretty cool. For example, this one. This is where the presenter goes over how to create assistants by doing API calls. Now, the two biggest announcements for me during the developer day were one, GPTs, and two, assistants. They're both similar in that they allow you to customize the OpenAI's model, the new GPT-4 with vision, whatever they're going to end up calling it. Right now, they're referring to it as GPT-4 1106 preview. But you're able to take that model and build your own sort of agents or chatbots or your own applications with it. Now, GPTs, the custom GPTs, are very powerful, and I think we're going to see amazing things emerge out of them. But they are purposely set up to be limited in certain important ways. And that is they can't be autonomous. They can't go out there and work on your behalf 24/7. Each time it runs, you have to prompt it. If you're doing an API call, you have to click I agree. You can only do one call at a time. You can't chain those together. As far as I know, as of this recording, it's limited in certain ways, which I think was part of the plan. Don't dismiss them because there's still a lot going on there. There's a lot of opportunity and a lot of applications that can be done just with GPTs alone. However, if you want to build your own autonomous agents using all the functionality that OpenAI provides right now, creating assistants with API calls seems like the way to go. It seems ungated, unlimited. There's no barriers to what you can do with it, or at least so far from what we've seen. The only problem is to really, truly be able to use it effectively, you do need to be a developer, be a software developer, have some coding skills and abilities, etc. Now, from talking to some of you who watch this channel, from doing various polls, etc., I would estimate that probably less than 1/3 of the people watching have really the high-level coding skills. Like that's their main job that they've been doing for the last 5, 10 years plus. The rest of the people that are coming in, they might be a little bit new. Maybe they've worked with code, maybe they haven't coded at all. And so one of my goals on this channel is to try to bridge the gap between people who, let's say, haven't really coded before and being able to do something like this. Because you no longer have to be an engineer or a software developer or coder to be able to have access to something like this. So in this video, we're going to do two things. One, we're going to go through her presentation and see what she's talking about because I think it's very interesting. We're going to see exactly what kind of power these assistants have. And two, I'll show you how to jump in and start coding something like this, even if you haven't ever coded before. If you're already a god tier developer, some of these might be a little bit basic for you, but there still might be some things you might be interested in. As we move forward in the next videos, we will be working on more and more advanced subjects regarding to this. But I wanted to do just a quick primer for everybody for whom all this just looks like gibberish. All right, let's get started. All right, so if you've never coded before and you want to follow along, I think this will be great. I'll show you how to build your very own AI app in under 2 minutes. Ready? Let's start. You're going to need two things. The first one is Google Colab. So just Google Colab. Should be the first one, and it looks a little bit like this. We're going to start a new notebook. Now, you might have to sign in with your Google account or whatever other account you want, but this is sort of under the Google umbrella and it's free, but you do need to sign in. And this is what that looks like. There's a lot of things going on here and you'll discover more of it over time. But really what you need to know is that it has code blocks like this, and you can add new code blocks like this, and you can delete them like this, and you can paste code in there and then hit play to run that code. This saves you the trouble of creating a development environment and worrying about what code you're running on your computer. This is all kind of in a simulation. It's safer. It's not going to break anything. Everything's on Google servers. So it's easier. It's faster. You have to think about less things. You can just jump in here and start coding, hitting play, and seeing what works. So this made the coding environment a lot simpler. The only other thing you need is the code. Where do we get the code? Well, how about ChatGPT? Now, ChatGPT just by itself, using GPT-4, the pro version of ChatGPT, it can do a lot. You can ask it to create code for you and it will just spit it out and you just put it into Google Colab and it will work. What I'm trying to cook up right now is, so far I'm calling it assistant coder. So there's a lot of words you can't use to name these things because if you're using certain words, it doesn't allow you to publish it. So if I can't say OpenAI or whatever, but this is my GPT that I'm building that's going to help me code these assistants. So the thing that she's doing right here, I want to be able to tell this GPT what I want to do, what I want that assistant to do, and have it give me the code I need to create something like this. This is work in progress. You're more than welcome to use it. Please jump in there, try it out. But it is work in progress. I am going to be improving it. There's a lot of things to be worked out. But over time, I'm hoping to develop this into something that will make creating these assistants and these API calls, it'll make it very effortless and simple and easy. But before we go there, let me just show you what you can do without assistance and just by using OpenAI API calls. So my assistant coder, I'm going to say, let's use Google Colab and OpenAI API to create the following. And so next I'm going to say what I wanted to create. Let's plot a chart of NVIDIA and Tesla stock price change year to date. So that was the example that was given in AutoGen. So using multiple agents to do that. So let's see how well this can generate the code for us. And so it's going to walk us through exactly how to do that. So step 1, set up a Google Colab notebook. That's exactly what we have right here. Step 2, install required libraries. So with a lot of this stuff, when we're writing with Python, which is the language that we're going to be using here, which is the language that's becoming kind of the go-to for a lot of these AI applications, usually on the first few lines, what you do, your first few commands is you install all the various libraries and modules that you're going to need, which is basically like the functionality that you're going to need to do whatever it is you're doing. In this case, since we're talking about stocks, we need Yahoo Finance. We're going to be using OpenAI, so we're going to import their libraries. And the way we install that stuff is we do this little pip install. You're going to see that a lot for various things, pip install this, pip install that. And so here we're pip installing Yahoo Finance. This is for plotting, it's like charts and graphs, etc., and OpenAI. You can also do this on 3 different lines by saying pip install this, then pip install that, and third line pip install OpenAI. So we're going to copy that bit of code. We're going to go to our Google Colab. We're going to paste it into that first code block, and we're going to hit play. Boom. And so what it's going to do, it's going to go ahead and install those libraries that we need in this environment, in this notebook, in this project that we're working on. So as you can see here, it's like saying, well, we already have some of these things, and then it doesn't have this thing, so it's downloading it. A lot of this, you're not going to need to understand it. You just need to think of these as little Lego pieces that you're putting together into some functionality. Over time, the more and more you use it, the more and more you'll understand what the different pieces mean. But don't get too bogged down with trying to figure out what each line means. That will come over time. But now because we have these coding AI assistants, it can be a little bit easier to start building and then learn as you go. You might have heard this referred to as just-in-time learning, right? So you're not relearning a bunch of concepts, you're just-in-time learning it to build the very next thing. So this is the output where it kind of tells us what happened. We don't need that. Let's just clear that. This has a check box next to it saying, okay, we did that part. All right. So the next thing that our assistant coder is telling us is we need to import libraries. So some of the stuff that we've installed, let's go ahead and import them into this project. All right. So what we're going to do is we're going to add another block of code and we're just going to paste that in there and we're going to hit run. And so what this does is it brings in all those modules that we need, all those tools that we need to make this run. All right. Next, we need to get our OpenAI API key. So an API key, it's your secret key that you get along with your OpenAI account. And basically, it's like the keys to your car, right? You put it in and it makes the car drive. So any piece of code that uses OpenAI API calls, it needs a key for it to happen. It also works a little bit like a credit card in that if you put in your API key and then you run functions that cost money. So for example, when you're generating certain responses, they cost money per token, right? Your OpenAI account gets charged that amount. So you got to be a little bit careful. You got to make sure to keep it safe. You don't want to give it out to anybody. Like you don't want to do a YouTube video and show everybody your code when tens of thousands of people are going to see it. That's a bad idea. Well, yeah, so we're going to copy this and we're going to put that we're going to create another code block and we're going to plop that right in there. And then we're going to get our API key in the OpenAI account. So you got to log into OpenAI, so platform.openai.com. Here on the left, we have our API keys. All right. And then we're going to click create new key. We can call it whatever. I'm going to call it test because I'm going to end up deleting it afterwards. And here's that key. We're going to copy it and we're going to replace this your API key with the actual API key. So that goes between the two single quotes like that. So we took the OpenAI key and we set it to this, which is our API key. We click run. And so that saves it. So now this file will remember that for whenever we have to use it next. All right. Next, fetch the stock data. And this is the little command that it gives us to do that. And so we're going to put that in there. We're going to hit run. So I get an error message because there's no symbol ticker Tesla. It's TSLA. Weird. So it's weird that I made that mistake, but there you go. So here we can just go ahead and, delete the E because the stock ticker name is TSLA. Let's try it again. Yeah, so it's completed. Okay, stuff like that happens every once in a while, but it's an easy fix. In fact, if we tell it that it made that mistake, it might actually fix it. Once we're done with this, I'm going to try to see if we can do that. All right. And next step is plotting the data. So we just copy this code, create a new block, put that in there and hit play. And bingo, as if by magic, AI magic. Here's that year-to-date stock price change for NVIDIA and Tesla. So from January to we're in November now. What's interesting, so we didn't even need OpenAI for any of this. None of this actually used OpenAI for anything. So we used Yahoo Finance to fetch the data, and we used this matplot library to plot the thing. But the next thing we're going to do is if we wanted to have a text analysis of the stock performance using GPT, we can do something like this, right? So it gives us the OpenAI API call we need to get that response back. As you can see here, we're going to use model text DaVinci. So it's one of the older ones. And the prompt is write a brief analysis comparing the year-to-date performance of NVIDIA and Tesla stocks. Let's try that. So we're going to create a new code, plop that in there and hit play. Now what happens is we get an error message because just now the OpenAI upgraded a lot of these commands because they're rolling out all the new models and stuff like that. So this is an outdated command. But as you can see, it gives you a README here that tells you how to upgrade it. That tells you how to solve that problem. Here it gives you the code that you would need to use instead. So I'm going to go back here. I'll actually create a brand new block here, post that in there. We'll take the prompt of write a brief analysis comparing the year-to-date performance of those two stocks. We're going to use this and we're going to put that as the content here. All right, and we're going to put our API key here and we're going to hit play. So what this did is sent this request to OpenAI, and OpenAI completed that request with the GPT 3.5 Turbo. Now by default, notice it didn't show the answer here. But we can do this print, but we can say print and then chat completion. As you can see here, we have the content that it gave us. The year-to-date performance of NVIDIA and Tesla stocks can be briefly analyzed as follows. And it gives us this whole long answer about the analysis. All right, so that might have looked a little bit weird, right? Because, right, we sent this completion request and then we had to print the completion request. But this is important to understand because that's exactly what we need to be doing when we're dealing with these assistants. You'll see why in just a second. But let me just say this. If you noticed, we built this whole app. If you know how to do this, you can probably do it in a minute or two. We used Yahoo Finance API to get information from them. We used a library that is able to create these graphical charts and graphs that's able to show it to us in these graphics. And we used the OpenAI API to write a brief analysis comparing the stock prices. I just wanted to show you what you can do with just Colab and ChatGPT, or in this case, this custom GPT. Notice I didn't write any of this code. Other than saying print here at the very end, I didn't write any of it. ChatGPT wrote it in its entirety. I told it what I wanted to do here, and it did all this and explained to me how to do it. Now the goal is to make this into something that's able to code assistance for me. So with that, let's go back to what this lady here is talking about. So this little presentation that she's giving, she's saying a couple important things. One is that you can create a new thing, let's say called assistant. And an assistant can be thought of as an agent that you've trained to do something specific. You gave it instructions, you gave it various documents to read, you gave it basically everything that you can do to a GPT. You've trained it to do a particular task, whether that's fetch stock prices or check the news or edit video or help you write or create images, whatever you can think of, you can create an assistant that does that. But here's the big difference. That assistant will be persistent, meaning it won't just disappear. It'll stay there and you can call upon it at any given time with an API call. And this is where that idea of a swarm comes in. We've talked about earlier, this idea of creating autonomous agents and really swarms of these autonomous agents, many of them working together to do the things that you want them to do. And each individual agent, in this case, is referred to as an assistant. So you can have 100 of them, 1,000, 1,000,000. And in a code like this, you call on each one with an API call. And then a code can have, 1,000,000 different calls as you're calling on one of them at a time to do whatever different task you want them to do. I apologize if this sounds confusing, but keep in mind, this is one video of many. We're going to get through this. But the first step is to understand what she did in this presentation and how you can do the same. So let's get started. So now we're going to go back here. We're going to ask our assistant coder, help me create an assistant. And it answers with this. Now, this isn't the answer it's going to give you normally. This is the new correct answer. This is the updated answer. And this took a long time to figure out how to do correctly, because otherwise it would just default to using its knowledge, which is out of date. And this is why I think this assistant coder will be so useful, because it'll have all the up-to-date stuff. It'll tell you exactly what you need to know, and it'll make this whole thing easier. So this is the correct code to do that. So let's copy and paste it over. I had to get really emotionally manipulative to get it to give me that answer instead of what it thought was the correct answer. So I posted that in here. So create an assistant. We're going to name it Math Tutor. Instructions, you're a personal math tutor. Write and run code to answer math questions. And for tools, we're going to use Code Interpreter. We're going to allow it to use Code Interpreter. And the model is this latest model, GPT-4 1106. So let's run that. Boom. So what it did here is it created that assistant in my OpenAI account. So if I go back and I take a look at my assistants, boom. As you can see there, it was created on November 15th, 7:50 p.m. I've been doing this so long, I just realized. All right. And the ID is that. So let me take that and we'll copy it. And just like we did up here with our OpenAI key, we're going to say assistant underscore ID equals 2, and we'll put that code here like this. We'll save that. So now in the future, if we need to talk to that assistant, that code will be saved. We just need to call it using assistant ID. Anyways, in the future, I'm hoping that the assistant coder will have all the answers, how to do all of this stuff. Right now, I have to slowly, one at a time, like just coerce it into giving the correct answers. But this is the new and updated documentations that they have here. This is the correct way of doing it. And so the next step will be to create a thread. A thread is like a conversation, like a back and forth conversation. All right, so we'll copy this. We'll throw that into our Google Colab like that, and we'll hit run. So that's done. It created a thread. By the way, when you run stuff, there's this little variables tab here. So you click on the box that you ran and it will show you the various variables. So it's basically all the information that gets saved and created is in there. So in this case, the thread ID is that in case we need it. So I'll do thread. And so as I'm typing it, it thinks that it should be this, which I think that is correct. And so we'll put the thread ID in there. We'll just run that and save that. And so then we can add messages to that thread and any documents that the user might be able to upload. So for example, here we're going to ask our assistant, I need to solve the equation, whatever. Can you help me? So we'll post that in here. All right, now that thread is created with the different messages, and now we have to print those messages. So remember, that's part of how the system is set up. So you send a request, it generates the request, but nothing else happens. It doesn't automatically spit it out.
With the new Assistants API, I don't have to store any messages in my own database. OpenAI handles truncating messages to fit the context window for me. The model output is generated even if I'm disconnected from the API. And finally, I can always get the messages that the model output later. They're always saved to the thread. I think that's pretty cool.
Then you can have that information go wherever you want. You can push it somewhere else. You can display it on screen, whatever. I asked ChatGPT how to print it after this happens, and it gave me this code. All right, so what this does is it adds that message to the thread. So the user says, hey, help me with this. Next, we run the assistant to answer the user. How do we do that? Well, it's this right here. We paste that in there, and it says, please address the user as Jane Doe. The user has a premium account, so we're going to hit play. So what that did is now the AI answered the question. So remember, everything's getting saved. The whole conversation is getting saved. If we want to see it, we just print it. But until we say print, it doesn't show up, or we can send it somewhere else so it's visible elsewhere, etc. And then this is how you display the assistant's response. All right, so I ran this code to get the back and forth messages. So as you can see here, the user asks, I need help with this equation. And the assistant answers, the solution to the equation is this. All right, so I know that might have been a lot. It might have been a little bit confusing. You're like, what is going on? But the point is, those are the building blocks of building your own back and forth assistant. Here's how to ask it questions. Here's how to give it certain tools. Here's how to extract answers. They are your basic building blocks of how to build an assistant. Let's take a look at this presentation. I think now that you've seen how to do it yourself, it might make a lot more sense. And then after, she'll also show you an application of how to do it. By the time we have the next video out, I'm hoping to have this assistant coder a lot more developed so you can just tell it in plain English what functionality you want the assistant to have. And it will go ahead and it'll create those assistants, give them roles, create the threads, etc. Now, if you've played around with AutoGen, as you might imagine, you can create multiple AI assistants with different roles, throw them all in one thread and have them talk back and forth to each other. You can do that with all these tools that we just went over. So I hope that made sense. I know it might have been, this is a little bit of an experiment that I'm doing. So hopefully I was able to bridge that gap a little bit. If you have any questions, let me know. If people have a lot of the same questions, I'll try to answer them in the next video. And check out this assistant coder. Again, it's going to be getting better and better every single day, I hope. And in the meantime, here's the rest of that clip from the OpenAI Development Day conference. Thank you for watching.
Now let's get started building our very own assistant. So I'm building a geography tutor app to teach my users about world capitals. I can get started in just a few API calls. And since you all are developers, I'm going to start out in my terminal with some curl requests. You can see my terminal here. Awesome. So we're going to start with the very first curl request. So now we want to create this assistant to power my geography tutor app. You can see we're posting to the assistant's endpoint, and we're passing two key pieces of information. The first is the model. We're using the newest GPT-4 Turbo model, the latest heat that just dropped today. Next, we're passing the instructions to the model. You can see I'm asking the assistant to be helpful and concise and letting know that it's an expert. When I send that request, I get an assistant back, and I can store that assistant ID for use later. Before the assistant's API, if I wanted to use these instructions repeatedly, I would have to send them on every single API request to OpenAI. Now, with the new stateful API, I can create my assistant once, and the instructions are stored there forever. Now, let's move on to the next primitive that Olivier mentioned, which is threads. Threads are kind of like one session between your user and your application. So now I've got a user on my website, and they're starting to type out a geography question, so let's create a thread. You can see here, we're posting to the threads endpoint, and there's nothing in the body because the thread is empty for now. We've got a thread ID, so just like before, let's save it for later. Cool. Now my user has finished typing, and I want to add their message to the thread. So let's do that. You can see here, I'm posting to the threads, thread ID, messages endpoint, and I'm passing in the data about the message. So the role is from the user because the user's typed out this message, and the content is their question. So they're curious, and they want to know what the capital of France is. Cool. So now you can see we've got a response back, we've got a message ID, and the message has been added to the thread. Now you're probably wondering, how can I get my assistant to start acting on this thread? So we've introduced a new primitive called a run, which is how we've packaged up one invocation of your assistant. So let's kick off a run now and get my assistant going. You can see here, I'm posting to the threads, thread ID, runs endpoint, and I'm passing in the assistant ID. This is pretty cool. You can actually have multiple different assistants work on the same thread. But for now, let's use my geography assistant. I'm going to kick off the thread and tell you a little bit about what's happening in the background. You can see I've got a run ID, and the run is queued. So a run is how we've packaged up all of the work of loading your models, all the messages in the thread, truncating them to fit the model context window, calling the model, and then saving any resulting messages back to the thread. So let's see what happened. We can fetch the messages on the thread to see how the assistant has replied. So I'm going to issue a GET request, the thread's thread ID messages endpoint, to see what there is. You can see we have the first message from our user, and then the assistant has replied saying the capital of France is Paris. So this is a super simple example, but we can talk about why this is better than the previous API. With the new Assistants API, I don't have to store any messages in my own database. OpenAI handles truncating messages to fit the context window for me. The model output is generated even if I'm disconnected from the API. And finally, I can always get the messages that the model output later. They're always saved to the thread. I think that's pretty cool. Great. So these are the basics of the API. And now let's move to what I'm most excited about, which is how we can power your application with tools. One of the most useful parts of assistants is their ability to leverage tools to perform actions autonomously. Code Interpreter is a tool that is hosted and executed by OpenAI. When I enable Code Interpreter in my assistant, I can expand its capabilities to include accurate math, processing files, data analysis, and even generating images. To optimize the quality and performance of these hosted tools, we fine-tune our models to best determine when to call these tools, what inputs are most effective, and how best to integrate the outputs into the assistant's response. So now, let's get started by using Code Interpreter. So I'm actually building a personal finance app that I want to ship to my users to let them analyze their transactions. And we've already been in the terminal, so let's move over to the OpenAI playground. Here, you can see the playground that you know and love. It's super useful for testing chat completions, but we've actually refreshed it, and you can see there's a drop-down in the top left to pick the Assistants tab. Here in the playground, you can see you can create assistants, change their instructions, and you can start threads. Super useful for testing. You can actually see the assistant I just created in the API. All of that information is loaded here as well. So now, let's create a new assistant to show off the power of Code Interpreter. I'm creating a personal finance assistant, so let's give it a name. I'm going to call it the Personal Finance Genius. And I'm going to tell it, you help users with their personal finance questions. Now, I'm going to select a model, and I'm going to select the newest GPT-4 Turbo. There it is. And I'm going to flip on Code Interpreter. With just one click or one line of code, you can enable Code Interpreter for your assistant. So let's save that. Great. So now a user has come to my application and they want to analyze a spreadsheet of their transactions. Let's take a look at what it looks like. You can see there's a bunch of info in here, a bunch of numbers. The dates aren't even sorted. It's pretty messy. Let's upload that to the thread. And now my user is asking for a chart. So generate a chart showing which day of the week I spend the most money. Awesome. So now I've done a compound action to create a thread, add a message, and kick off the run. You can see things are happening in the background. Let's talk about what's going on. When we've kicked off the run, we will get all of the messages on the thread, summarize them for the model to fit the context window, determine if it's called any tools, execute the tools, and then give that information back to the model. So let's take a look. Oh, here we go. We've got the output, actually. It's actually pretty surprising. I did not think I'd be spending the most money on Sunday. Let's look at how we got here. You can see that our personal finance genius has started by telling us what's going on. It's actually written some code. We can click into the code here, and then it kept writing some more messages, and finally generated a chart, which we were able to see. So we can actually look a little more deeply to see how this happened. We can look at what we've called steps. Steps are basically the logs for your run, and they're super useful so you can render your own rich UIs to show your users what's happening. You can see the logs tab here. I can open it, scroll down, and find the steps for this run. This is reverse cron, so I'm scrolling to the bottom, and I can show you how we got here. So first, you can see we've created a step, and it has type message. So that corresponds with this first message we've created. Next, you can see there's a run step that is a tool call, and it's for code interpreter. So this is how the playground was able to render this snippet. The inputs and the outputs are directly in the API. Next, you can see another message creation step corresponding to this message, and then there's a few more code interpreter and message snippets. So all of this information is sufficient for you to render the same UI. The playground is actually built entirely off of our public APIs, so you can do the same. And speaking of, this is exactly what ChatGPT does under the hood when they're using Code Interpreter. So you can skin your application to look however you like. Great. Now let's move on to retrieval. The retrieval tool is incredibly useful when you want to expand the knowledge of your assistant. Maybe you have some information about your app or business that you want to imbue your assistant with. Rather than having to implement custom retrieval system on your end, OpenAI has built a tool that you can use with one line of code or one click in the playground. The retrieval tool does all of the document parsing, chunking, generates embeddings, determines when to use them, so you don't have to. Let's get started. So I'm going to hide the logs, clear this thread, and create a new assistant. So now I'm actually building an assistant to help my users, use the OpenAI API better. So I'm going to create the OpenAI API wizard. That looks pretty good. Now I'm going to tell it that it's a helpful assistant and then use the attached docs to answer questions about the OpenAI API. So I'm actually going to upload. I have a full dump of the OpenAI docs, just a markdown file, didn't process at all. I'm going to attach it to the assistant, and I'm going to flip retrieval on, just one click. Finally, let's pick the new GPT-4 Turbo model and save our assistant. So while this is being saved, we're actually doing the work on the backend to make this data accessible to the assistant. So let's see what it looks like when my user asks a question about the OpenAI API. So my user is curious, and they're wondering, how do I use the embeddings API? And so now we've kicked off a run. Again, what's happening in the background here is we're fetching all of the messages, truncating them however needed, calling the model, determining if the model has called the retrieval tool, executing retrieval for you, and then giving that back to the model to summarize. You can see here, we've actually grabbed a snippet from the docs, and we even have a citation giving a direct quote from our docs so we could render that for the user. I think that's pretty cool. Just like last time, we can take a look at the steps and see how we got here. This one's a little simpler. First, the tool call to the retrieval tool, so you can let your user know that's happening while it's going. And then we have a step for message creation, so you can render this UI. Awesome. So now back to Olivier to explain how you can use the retrieval tool with different levels of file scope.
Knowledge retrieval is extremely useful to augment the knowledge of your assistant with data from outside of the models. Concretely, retrieval can work in two different ways. Number one, you can upload and pass files at the assistant level. That's useful if you want your assistant to leverage that knowledge in every single interaction, in every single threads. So for instance, in Michel's example, on the customer support and the API docs, you should likely pass that information at the assistant level. The second option is to pass files at the thread level. That's useful if you only want that specific thread to be aware of that content. So if I'm uploading my personal bank statements, I should likely do it at the thread level. Behind the scenes, retrieval takes care of, sometimes it even do not do vector search, and instead stop the context. So you don't have to essentially handle that logic on your end. And we're excited to launch several new features over the coming month. For instance, we want to allow you to pick between different strategies to find the right balance between cost, accuracy, and latency. One final reminder, OpenAI never trains on any files or data that you pass to the API. And so that's the same for retrieval files. All right, let's move on to the last category of tools, function calling. So again, function calling are custom functions that you define to the models, and the model selects those functions on your behalf. We are excited to release two new features to function calling starting today. The first one is JSON mode. With JSON mode, the model will always return valid JSON. Behind the scenes, we made model improvements and improvements to our internal inference stack in order to constrain the sampling of the model and to make sure that every time the output complies with JSON syntax. So that's pretty useful. That means that you can trust that the model generates JSON that you can directly execute on your end. That's pretty cool. And by the way, JSON mode will also work outside of function calling. So if you use, for instance, the chat completions API, and you have like a very simple application that just like takes in data, extracts like some fields, convert it to JSON, JSON mode will work as well. The second improvement to function calling is parallel function calling. With parallel function calling, the model can call multiple functions at a time. We've seen in many applications, users giving multiple instructions at once to an assistant. So let's say, for instance, I'm building a car voice assistant and I tell the assistant, raise the windows and turn on the radio. Before parallel function calling, that meant that you had to do 2 different model calls to OpenAI, which of course result in extra latency and cost. With parallel function calling, such a use case can be handled with one single call, which is pretty awesome. All right, let's do a demo now of function calling.
Awesome. Back to the demos. So I'm building off Olivier's example, and I'm building a new type of car. And I want a voice-activated assistant to be able to use some of the features of the car. So I have a bunch of functions that I've implemented. So let's pull up an assistant I've previously created. Here it is. So I previously created this car assistant, and I've told it it's a helpful in-car assistant and to please call the appropriate function based on the user's request. So with function calling, I have an assistant with all of my functions, and my assistant will tell me when to call my functions based on the user's input and what the most appropriate arguments are. This is super helpful, so I can figure out how to use my system to answer the user request. So let's take a look at some of the functions I have here. So I have a lot of the stuff you might expect to see. So honk horn, start phone call, send text message. So let's try it out. There's a user in my car, and they just said, that guy just cut me off. Let's see which function the assistant determines makes the most sense to call. There it is. Our assistants decided to honk the horn to let that guy know it wasn't cool. You can see here that we've called the honk horn function with no arguments, so now I know how to pass it to my system. We also have a way for you to give the function output back to the assistant so it can keep going. So here, I'm going to enter the output. It was successful. Oops, I have a typo there, but that's all right. We're going to keep going. And the assistant says, I've honked the horn for you. Please stay calm. So actually, I'm realizing that there's a function here that's missing that I want to add. So let's show you the add function flow. You can see there's a button here where I can add a function. We have some helpful presets to get you started. So let's use the get stock app and change it a little bit to be my function. So I actually want a function to be able to change the volume in the car. So I'm going to call it set audio volume. And I'm going to give the description to the assistant. So set the car audio volume. Now we need to tell the assistant how to call this function. So we can tell it about the parameters and whether or not they're required. So the main parameter for my function is the volume. And actually the volume isn't a string, it's a number. And so this is the volume to set, and it's 0 to 100. Finally, we'll tell the assistant that this is required when you're calling this function. Great, this function looks good, so let's save it. And now I can save my assistant. You can see here the new set audio volume function is listed on the left. Let's start a new thread. And now my user is asking for a different query. They're saying, play Wonderwall and crank it up. In the background, my assistant is determining which of these functions makes the most sense to call. You can see here we've got the output, and there's actually 2 functions. This is showing you the power of parallel function calling. The first function starts the music with the query Wonderwall, makes sense. And the second sets the audio volume to 100, pretty cranked up. Now I can execute these in parallel and then get back to the assistant. Awesome, we're super excited about parallel function calling. And let's recap everything we've launched today. We're super excited to see what you build with the new Assistants API. We've added 3 new stateful primitives: the assistant for storing instructions, models, and tools, threads for keeping track of all your conversations, and messages, which are between the user and the assistant. We've also added the runs primitive for every time you want to invoke an assistant, and we've added steps, which are useful logs for rendering your UI based on what the assistant is doing. Finally, we've launched 2 new tools, code interpreter, retrieval, and we've made 2 huge improvements to function calling, JSON mode, and parallel functions. We're super excited to see what you build. And now over to Olivier to tell you about what's next.
Thank you, Michelle. So that was a lot, but there is a lot more coming soon. We plan to ship many new improvements to the Assistants API in the coming months. Number 1, we want to make the API multimodal by default. It should be able to accept and generate images and audio file. Number 2, we want to allow you to be able to bring your own code execution. So you can execute on your end the code that was generated by the assistant. A third big feature that we want to ship soon is to ship asynchronous support with WebSockets and webhooks to make it easier for real-time applications to use the API. It's a new feature. It's a new product. It's in beta. We would love to hear what you'll build. If you have any feature requests, any wish lists, please tweet at us at OpenAI and show us what you build. We would love to hear all about it. Thank you so much and enjoy Dev Day.